wind turbines extract kinetic energy from wind, and transform it to electricity. In this video we will learn working principle of horizontal axis wind turbine, which is the most commonly used one. When wind with high energy passes over specially shaped wind turbine blades, it induces a lift force. Tangential component of lift force will make the blade rotate. This low-speed rotation will be transformed to high speed, with help of gear mechanism inside nacelle. A generator in nacelle will transform mechanical energy obtained to electrical energy. Direction of wind can change at any time. So a yawing mechanism in turbine makes sure that turbine is always in direction of wind, thus assuring maximum power extraction. Most often, wind speed will have dramatic fluctuations with time. Power produced by wind turbine is highly sensible to wind speed. So unless if you don't have a suitable mechanism, power produced will be highly fluctuating, which is undesirable. In practice, wind turbine starts only when there is a minimum speed to wind, called cut-in speed. When wind speed is between cut-in speed and a rated speed, there will be varying power production. After rated speed, power production is maintained at constant level. This is achieved by adjusting pitch of the blades with help of a controller. Higher wind speed may be fatal for wind turbines, so after a cut-out limit power production is turned off. In effect, power produced by wind turbine will vary like this with wind speed. Such a profile will give much smoother power production. Next, we will see what is the maximum performance a wind turbine can have, using a simplified one-dimensional analysis. Since the turbine is extracting some energy, at outlet wind will have lesser kinetic energy, compared to inlet. So at exit wind velocity will be lower compared to inlet. It will follow a trend like this from inlet to exit. Mass flow rate passing through blade swept area is given as wind velocity at blade times density into area. Wind velocity through blade can be approximated as average of inlet and exit velocities. Since velocity at inlet is higher than outlet, the same mass will flow through inlet and outlet through a smaller and bigger area. So the fluid passing through swept area will follow a flow volume like this. Power extracted by the wind turbine is same as decrease in kinetic energy from inlet to outlet. So wind turbine can extract maximum energy when product of these two terms are maximum. Power extracted will vary like this, with ratio of exit to inlet velocity, and will have a maximum value when exit velocity is 1/3 of inlet velocity. Power input to wind turbine is inlet kinetic energy of wind passing through same swept area, which can be modified in terms of velocity. Efficiency of wind turbine is ratio of power extracted to power input. So we can show that a wind turbine can convert up to 59.26% wind kinetic energy to work. This is known as Belt's limit. But this is an idealistic case, possible only when wind turbine is rotating at high RPM and having infinite number of blades. A real turbine will have much lower performance. We will learn about factors which affect wind turbine design in next video.